Now today we will be calculating this value so that we understand कि value अगर कम है तो it is easy और अगर value ज़्यादा है then it is difficult for controllability and observability. When I have those values, I attain certain advantages. These four are the listed advantages. Firstly, why we need this observability and controllability to be calculated is to analyze the difficulty in testing the internal nodes, because the circuit is very big for nowadays. तो उसके अंदर इतने सारे internal nodes हैं, which internal nodes we are not able to observe or control. We will eliminate those faults and try to cover those faults using some other faults, ताकि एक टेस्ट पैटर्न मल्टीपल फॉल्ट्स कवर कर सकता है. तो हम ऐसा कोई फॉल्ट कवर कर लेंगे जो इनको एक्सेस नहीं करना पड़े, राइट. सो वी नीड टू हैव एन एनालिसिस फॉर दैट. सेकेंडली, वी मे नीड टू मॉडिफाई द सर्किट. अगर बहुत ज्यादा नोड्स ऐसे आ गए कि जिनको हम ऑब्जर्व नहीं कर पा रहे, कंट्रोल नहीं कर पा रहे, सो देन वी नीड टू मॉडिफाई द सर्किट. We need to modify the connections. We may need to modify the number of logic gates. Maybe we need to increase the logic gates. XOR logic लगा रखा है हमने, उस वो control नहीं कर पा रहे. Then we shall replace that XOR using an AND and an OR. So we need to change the circuit so that the circuit becomes observable and controllable. Also, this can be given as an aid to ATPG algorithm. ATPG algorithm क्या थे? जो एल्गोरिथम हमने फॉल्ट टेस्टिंग के लिए यूज किए थे फॉर कॉम्बिनेशनल एंड सीक्वेंशियल सर्किट्स. तो उसमें जो सिग्नल्स आर इजीली कंट्रोलेबल, वी ट्राई टू टारगेट देम फर्स्ट. हमारे पास फॉल्ट लिस्ट है बिकॉज इनपुट वाज अ फॉल्ट लिस्ट. इस फॉल्ट लिस्ट में कौन सी फॉल्ट शुड वी टारगेट फर्स्ट, दैट कैन बी कंसिडर्ड यूजिंग दीज डेटा फ्रॉम कंट्रोलेबिलिटी एंड ऑब्जर्वेबिलिटी. And lastly, these can be used to estimate the fault coverage and the vector length. We'll see how this vector length is related to the values of controllability and observability. जब हम controllability और observability की बात करते हैं, then we have these 6 measures which we call SCOAP measures. SCOAP stands for Sandia Controllability Observability Analysis Program, right? These give me the exact value. The value may range from 0 to infinity. But there are other measures also where the probability is taken into consideration, probability of setting the signal, right? We won't be going into that because controllability and observability are easily measured using SCOAP. So हमारे पास 6 measures हैं. The first 3 measures are referred to with combinational circuit, and the last 3 are for sequential circuits. Definitely sequential circuits को treat करना is different than combinational circuit. So we'll begin with combinational circuit and then slowly move towards sequential circuit. तो जब हम controllability की बात करते हैं, then we say we have CC0 and CC1 for any wire L. किसी भी wire L पर if I want to establish a 0, then the controllability is set to be CC0. So CC0 is basically the difficulty in putting a 0 on wire L. Similarly, CC1 is difficulty in putting 1 on wire L. ठीक? Observability is COL. Observability is irrespective of 0 or 1, because observability means जो भी fault हुआ है, that is required to be propagated towards output. So it is independent of the value, right? Similarly, sequential के लिए sequential controllability for 0, so we call it SC0. Sequential controllability for 1, we call it SC1, and sequential observability is SO. आशीष इसको चला दो तो तुम्हें यहाँ दिखेगा. Let us look at calculation for controllability first. Controllability is always measured from primary input towards primary output. तो अगर ये मेरा combinational circuit है, I have certain primary inputs and I have certain primary output. So when I talk of controllability, I should start with primary inputs. I should assign the value from primary input, and gradually I should move towards primary output, right? जब हम observability की बात करेंगे, then from primary output we will move backwards towards primary input. ठीक? तो first step is set the controllability for PIs. Initialize the controllability for PI. PI क्या है? एक direct signal है which I can control. I can give any value. Therefore, we begin by putting CC0 as 1 and CC1 as 1 for all the primary inputs. Means the controllability for putting a value 0 is set to 1. Controllability to set 1 is also equal to 1. ठीक है? Now we move to next level. Level means that if this is my circuit, I should start from primary inputs A, B, C. Then I should move to level 1 gates and I should analyze all the gates which lie in level 1. Where level 1 simply means कि आपको कितने logic gates पार करने पड़े to reach that particular logic gate. For example, here the NOT gates. These are directly connected to primary inputs. The gate number 1 is connected to A, gate number 2 is connected to C. So this is level 1, right? The AND gate is representing level 2 because now I have two steps. One is the primary input. I need to control the primary input. Then I need to control the NOT gate, which gives me the input to this AND gate. So the level is 2. The output of this AND gate is given to gate number 4 and 5. So they become level 3 gates. And the output of level 3 gates go to gate number 6. So this becomes level 4. So we start from PIs. Then we analyze all the logic gates for level order 1. Then we analyze all the logic gates for level order 2 and so on. So that level 1 ka output is given as input to level 2. Level 1 का output is given as input to level 2. तो अगर मैंने level 1 के सारे calculations कर लिए, then it will be easy to work with level 2 because that will use the previous lines, right? So we move in the level order and keep on assigning this value of CC0 and CC1 to each wire depending upon this formula. Fine? हमने इनपुट को सेट किया, प्राइमरी इनपुट को. नाउ आई वांट कि इस गेट के आउटपुट पर कंट्रोलेबिलिटी क्या होगी, हाउ गुड आई एम एबल टू कंट्रोल द वैल्यू एट द आउटपुट. देयरफॉर द आउटपुट कंट्रोलेबिलिटी हियर is defined based on these three conditions. The first condition says that if only one input sets the output, for example, an AND gate. AND gate का output will be 0 when at least one of the input is 0. So I can obtain this 0 by setting only one input. चाहे 2 input हो, चाहे 4 input हो AND gate के, but if I set any one input to 0, I will be able to set the output to 0. So the controllability will be given, CC0 at the output will be given as the minimum of the input controllabilities, right? Controllability किसकी? A pin की, B pin की. ठीक है? A is my input जिसकी दो controllabilities है, CC0 और CC1. B is another input. Again I have two controllabilities to set it equal to 0 or 1. So CC0 and CC1. इन दोनों में से जो भी minimum होगा, that will be assigned the controllability CC0 for the AND gate. So your first statement says that if only one input sets the output of any logic gate, the output controllability will be given as minimum of input controllabilities. ठीक है? +1 हम हमेशा करेंगे to indicate the change in the level order. Because हम एक level increase कर रहे हैं, so the next level will be +1. ठीक? If I am not able to set by putting any one input, but I am required to set all the inputs, in that case, the output controllability will be equal to sum of all the input controllabilities +1. अगेन हियर द एंड गेट का आउटपुट 1 कब होगा? जब उसके सारे इनपुट्स 1 होंगे. So I am required to set all the inputs to 1, right? So I should use CC1 for all the inputs and add them. ठीक है, हमने सारे इनपुट्स को 1 सेट किया है, तो हर एक की कंट्रोलेबिलिटी टू सेट 1 is summed up together and +1 indicates the level order. Right? Third case, there are more than one input set which give me that value. For example, an XOR gate. XOR के लिए 0 0 0 1 1 0 1 1. The output will be given as 0 0 if the inputs are 0 0 and 1 1, and 1 for 0 1 and 1 0. So in this case, the result depends upon the setting of 2 inputs, and that too at both the inputs pins, right? So 0 1 set करो चाहे 1 0 set करो. So in that case, I need to calculate the minimum controllability of either of the cases. 0 1 set karna means, look at this XOR, the second last gate, this is XNOR. XOR is not here, okay, XNOR. Third gate, yes, XOR. So XOR का output equal to 0 कब set होगा? जब या तो दोनों इनपुट 0 हो जाए या दोनों इनपुट्स 1 हो जाए. So दोनों इनपुट 0 means CC0 for A plus CC0 for B. It means this indicates the set 0 0, the input value 0 0. Second case में दोनों 1 हो जाए तो CC1 of A plus CC1 of B, right? इन दोनों में से कोई भी एक कंडीशन हो जाएगी तो मेरा आउटपुट विल बी 1. Therefore, I choose the minimum of the two controllabilities. The controllability to set input equal to 0 0 or the controllability to set input 1 1. दोनों में से जो भी कम होगा that will be taken up as CC0 for the output of XOR gate. 1 कब सेट होगा XOR गेट का? जब इनपुट 1 0 या 0 1 होगा. So 1 के लिए CC1 for first input, CC0 for second input. This gives me the first case of 1 0. The second case is 0 1. इन दोनों में से जिसकी भी कंट्रोलेबिलिटी मिनिमम होगी that I will take to assign CC1 and add 1 for level order. ठीक है? Look at the second gate, that is your OR gate here. OR gate का आउटपुट 0 कब होगा? जब दोनों इनपुट 0 सेट करने पड़ेंगे. It means I should sum CC0 for A and CC0 for B because दोनों इनपुट को मुझे 0 0 सेट करना है. So I take the CC0 for output of the OR gate as the sum of controllability CC0 for both the inputs plus 1. Fine. When will be the output equal to 1 for the OR gate to define CC1? When at least one of the input is 1, right? So I should take the minimum controllability. So minimum of CC1 of A or CC1 of B, जो भी minimum हो. अगर 3 inputs होंगे then I'll take minimum of CC1A or CC1B or CC1C. ठीक? Plus 1 for level order. Similarly, you can verify for all the other logic gates. Fine. We'll keep on doing this as we do with the circuit. So we start with this circuit. The first step was to assign the primary inputs with the basic controllability 1 1. तो मैंने A को दिया CC0 is 1, CC1 is also 1. I write the controllability with the set CC0 followed by CC1 for every wire. तो PI में सबका 1 1 हो गया. Right? Now this A is giving a fan out. Right? तो ये 1 1 controllability will reach here. Also the same controllability will reach here. Right? अगर किसी वजह से दोनों की controllability अलग अलग होती है then we will take the minimum value. फाइन. अगर यहाँ पे 2 बार वैल्यू कुछ आ रही है, देन फैन आउट में आई विल टेक द मिनिमम. So I have all the inputs controllabilities defined for level 1. So I start analyzing with level 1. Now I need to define CC0 at the output of NOT gate. What will CC0 means? Controllability to put the value equal to 0. इसकी वैल्यू 0 कब होगी आउटपुट की? लेट अस स्टार्ट विद गेट 1. गेट 1 का आउटपुट विल बी 0 अंडर व्हाट कंडीशन? इनपुट इज 1. तो इनपुट की 1 की कंट्रोलेबिलिटी will be used here to calculate CC0 at the output. So CC1 for input is 1. So what should my value here be? CC0 will be 1 plus 1. एक तो इनपुट का plus 1 to indicate the change in level. Right? So CC0 का वैल्यू कितना आ गया? 2. We are trying to get a numerical value as to how much difficult it is control to put a value on this pin. This was the first initial step to start with calculation with the controllability. We put CC0 and CC1 for the primary inputs to be 1. Because we are talking of controllability which we do with primary inputs, so we always move from primary inputs towards primary output. So we initialize the primary inputs with the initial value 1 1, the easiest to put, right? 0 means not controllable, वो तो है नहीं. I can put in value at the primary input at least, so I will get the value minimum as 1 1, right? Now the CC0 for output of NOT gate 1, this comes out to be 2. It means this is definitely more difficult as compared to primary inputs, because now I have to tackle one level of logic gates, right? What will be the CC1 for this output? Output 1 कब होगा इस NOT gate का? जब इसका input 0 हो. तो input 0 की controllability कितनी है? 1. So what will be CC1? It will be the input की controllability as 0 plus 1. So the value will be 2. Right? I am using this thing, the last gate. The controllability to put this value equal to 0 is equal to the controllability to put input as 1 plus 1. The controllability to put the output at 1 is given as controllability to put input as 0 plus 1. Right? Find out what will be the controllabilities CC0 and CC1 for the output of NOT gate 2. 2 and 2. Right. Because इसका output 0 कब होगा? जब input 1 होगा. तो input 1 की controllability is this second value in the ordered pair. So 1 plus 1 gives me 2. The output of the NOT gate will be 1 when the input is 0. So I use this 1 plus 1 due to level change. So it becomes 2. So my level 1 is completely worked out. I get the controllabilities at the output of level 1. Now I begin with level 2. Level 2 consists of an AND gate, right? जिसकी input controllability अब मेरे पास है, इस वायर की भी 2 2 है, ऊपर वाले वायर की भी 2 2 है. Now when will the output be equal to 0 for the AND gate? कोई भी एक input अगर 0 हो जाए, then the output will be equal to 0. It means I should use the minimum value. Minimum of controllability of 0 at the inputs. Right? तो input CC0 कितनी है? इस वायर की 2, इस वायर की 2. So the formula becomes minimum of CC0 of one input, comma CC0 of the other input. अगर दोनों में से कोई भी एक 0 हो गया, then in that case my output will be equal to 0. So the formula of the value becomes minimum of 2 comma 2 plus 1. So the answer should be 3. So the CC0 value for the output of the second level gate is 3. Definitely even more difficult to control as compared to the output of NOT gate, because now I am at level 2. Right? Find out what will be the controllability CC1. Output of AND gate will be 1 when both the inputs are 1. Right? अगर दोनों input 1 होते हैं तो उस केस में क्या होता है, मेरा sum हो जाता है. So what will be CC1 at the output of the AND gate? CC1 of A plus CC1 of B plus 1. तो पहले वायर का 2, दूसरे वायर का 2 plus 1. So means 5. Now if you observe here, level 3 में CC0 सेट करना आसान है as compared to CC1. Definitely CC0 सेट करने के लिए I need to work with either of the wire at the input. But if I want to set 1 at the output of level this logic gate 3, I need to control 2 wires. Therefore the controllability is having a higher value here. Right? Level 2 has been worked out. Now work with level 3. Level 3 has 2 gates. इस गेट के इनपुट्स कितने बनेंगे कंट्रोलेबिलिटी? दिस इज 1 1 फाइन फ्रॉम ए. दिस वायर कम्स फ्रॉम बी एज अ फैन आउट. तो बी का कंट्रोलेबिलिटी इज 1 1. सो यहां पे भी आई शुड रीड 1 1. दिस लास्ट इनपुट ऑफ द नॉर गेट कम्स फ्रॉम output of gate 3, whose controllability we calculated as 3 5. So the input controllability of the third wire will be 3 5. Right? Similarly here the upper wire will have controllability 1 1 from B. Here the controllability will be 3 5 from the output of gate 3. Right? Now find the output of the NOR gate, controllability for output of NOR gate. NOR gate ka truth table 0 0 0 1 1 0 1 1. This is 1, rest everything is 0. So when will be the output of NOR gate equal to 0? जब कोई भी एक input 1 हो जाए, then your output of NOR gate will be 0. It means you need to control any one wire. So therefore its CC0 will be given as minimum of controllability to put value equal to 1 at input. So इसका मतलब CC1 of the first input, CC1 of the second input and CC1 of the third input. इनमें से जो भी minimum होगा that value plus 1. So which one is minimum? इसका CC1 is 1. इस वायर का CC1 is 1, इस वायर का CC1 is 5. So the minimum of 1, 1, 5 is 1. So 1 plus 1 gives me 2. ठीक है, एक तो यहां से आया minimum of 1, 1, 5 is 1 plus 1 gives me the controllability as 2. CC0 becomes 2. What will CC1 be? When will be the output equal to 1? When both the input are 0. So how do I define? I define it as CC0 for A plus CC0 for B plus 1. Plus C भी तो आएगा. CC0 for C plus 1. So 1 plus 1 2 plus 3 5 and plus 1 due to level change. So it becomes 6. So the controllability of the output of gate 4 becomes 2, 6. What will be the output controllability here at the output of gate 5? This is an AND gate. AND gate का output 0 कब आएगा? जब कोई भी एक input 0 हो जाए. So minimum of CC zeros of the inputs plus 1. कितना है CC 0? एक 1 है, एक 3 है. So the minimum value is 1. Add 1 to it. So it becomes 2. What will be CC1? दोनों का sum? No. Yes, दोनों का sum, because the output will be 1 when both the inputs are set equal to 1. So 1 plus 5 plus 1. So 7. So the controllability at the output becomes 2, 7. All the gates for level 3 are analyzed. Let us analyze for level 4. Well, first we carry the controllability towards input. So 2, 6 is the controllability at this input, and here it will be 2, 7 due to this fan out, right? Now if the controllabilities at input of the OR gate are given, what will be the controllability? CC0. 0 कब होगा आउटपुट? जब दोनों वैल्यू 0 हो. तो इसका मतलब CC0 of A plus CC0 of B plus 1. So it means 5. When will be the output equal to 1 to give you CC1? Any input 1. So the minimum value is 6, 7 में से 6 plus 1. So 7. So the controllability of wire Y comes out as 5, 7. Now since we have completed all the levels, now we talk about the outputs. What will be the controllability for Z? This 2, 7 is fanned out here. So the value of controllability is 2, 7. What about X? This 3, 5 is fan out. So this becomes 3, 5. Right? So I have the controllability defined for every wire now. 2, 7. Okay. Any problem in this calculating controllabilities? Simple है. Only the formula you need to take care is, अगर एक input set करना है, then you take the minimum of those CC values, controllability values. और अगर सारे input set करने हैं, then you take the controllability of all the inputs and sum them. अगर एक से ज़्यादा set है to give the value as output, then you take the minimum for that set. Like 1001 अगर होता, तो you calculate the controllability to set 01 and controllability to set 10 and take the minimum of those. ठीक है? Now once we have controllabilities defined, we start to work for observability in the opposite direction. Now to calculate the observabilities, we will start from primary outputs and will move towards primary inputs, right? So we compute observabilities in reverse pass, starting from POs, moving backward to PI, definitely by level ordering only. सबसे पहले हम level 4 को address करेंगे, then we will address all the logic gates for level 3, then we'll address all the logic gates for level 2, then 1, and finally my primary inputs. I will write the observability after this bracket, so that all the things are available in the same case, right? Bracket के अंदर मेरी controllabilities है CC0 and CC1. Bracket के बाहर I will start writing observability, which is only a single value. It does not depend or differentiate between 0 or 1. To set the output observability, we start with CO equal to 0 for all the primary outputs, क्योंकि उसको ऑब्जर्व करना ही नहीं है, जो भी वैल्यू आ रहा है दैट इज ऑलरेडी गिवन. सो वी initialize the value as 0, unlike the controllability was initialized as 1, because you need to put some efforts to put in the value. So that was 1. Here the observability is 0. Then for a particular logic gate, we will move backward. We'll have the output controllability given. Then I need to calculate the controllability of, observability of inputs. So the input observability will be given as the observability of the output plus the controllability for putting the other input to non-controlling value. Non-controlling value हमने क्या बोली थी? वो value जिससे आउटपुट पर इफेक्ट नहीं हो, राइट. सो इफ वी टॉक अबाउट नॉन कंट्रोलिंग वैल्यू ऑफ एंड नैंड, the non-controlling value is 1. क्योंकि अगर एक इनपुट मैंने 1 कर दिया तो आई एम नॉट श्योर अबाउट द आउटपुट विच इज गवर्न्ड बाय द सेकेंड इनपुट. अगर दूसरा इनपुट 0 हो गया तो आउटपुट 0 हो जाएगा, दूसरा इनपुट 1 हो गया तो आउटपुट 1 हो जाएगा फॉर द एंड गेट एंड रिवर्स फॉर नैंड गेट, राइट. और गेट और नॉर गेट के लिए it should be 0. Fine. So here for AND gate, if I have the observability at output, I can calculate the observability at A by using this formula. Observability at output plus controllability for putting other input to non-controlling value. इसका मतलब CC0 will be COZ plus CC1 of this other input, yani B, CC1 of B, because this is AND gate. Plus 1 again to indicate the level order. We are changing the level order, so the complexity increases by 1. The difficulty increases by level 1. Right? Let us do it for the circuit that we did for controllability. We start with observability from output. So the output observability is initialized as 0 x, 0 for y, 0 for z. Now I move to level 4 first. Level 4 के output की observability is 0. Find out what is the observability for this lower wire where the controllability is 2,7. What is its observability? Observability क्या होगी? Observability of output yani 0 plus controllability to put value equal to 1 at the other input because 0 at the other input because this is OR gate. OR gate ka non-controlling value is 0. So what will be the observability here? 0 plus 2. CC0 of the other wire. So that is 2 plus 1. So this gives me 3. So the observability at this wire is 3. Right? Find the observability at the wire where the controllability is 2,6. 3. कैसे? Output की controllability which is 0 plus CC0 of the other input. CC0 is 2. So this becomes 3. अभी हम फैन की बात नहीं कर रहे, हम तो आउटपुट से इनपुट की तरफ आए हैं, केवल लेवल 4 की बात करिए हम. जब मैं 2,6 वाले वायर के लिए निकाल रही हूं then I am considering it for this lower wire. The other input to be set equal to non-controlling value here. Right? I am talking about the other input. So when I am calculating the observability for the wire with controllability 2,6, I am considering it for the wire here. Then तीनों use करेंगे, उनमें से minimum लेंगे. Right? Now level 4 completed. So move to level 3 and use the last calculated observability value at the output of level 3. So this 2,6 has the observability of 3 which is carried out here. So this also gives me the observability as 3. Also 2,7 with observability 0 comes down here. So I get the observability as 0.
Not considering 3 over there.
Where?
This 3 is the fan of the cutter.
Okay, yes, we should consider it here. This is a fan out. Fan out की एक की observability is 0, दूसरे की observability is 3. So I will take the minimum. राइट. सो मिनिमम मेरा कितना है, इसका 0 है, इसका 3 है. सो आई शुड चूज द मिनिमम वैल्यू, बिकॉज मुझे क्या करना है, ऑब्जर्व करना है. तो मैं इस पाथ से जाऊंगी तो मेरी ऑब्जर्वेबिलिटी 0. इस पाथ से अगर मैं जाने की कोशिश करूंगी तो ऑब्जर्वेबिलिटी इज 3. वाई टू इंक्रीज द डिफिकल्टी, व्हेन इस वायर की फॉल्ट आई कैन ऑब्जर्व डायरेक्टली थ्रू दिस वायर विद मिनिमम ऑब्जर्वेबिलिटी, व्हाई शुड आई गो फॉर दिस वायर. So my ATPG algorithm if gets this information कि इस पाथ से जाने पर observability value is 0 और इस पाथ से जाने पर observability value comes out to 3, so it will use the path with minimum observability so that it has lesser effort, right? So the value becomes 0 here. Now come to this NOR gate, gate number 4. I have the controllability of the observability of the output. What will be the observability at the first input of the NOR gate? It will be the observability of the output plus the controllability to put the other input at non-controlling value. Non-controlling value of NOR is 0. So इस वायर जो ऊपर सबसे ऊपर वाला वायर है, इफ आई वांट टू कैलकुलेट द ऑब्जर्वेबिलिटी ऑफ द फर्स्ट वायर, आई शुड कंसिडर CC0 फॉर द रेस्ट ऑफ द वायर्स, राइट, एंड आई शुड ऐड ऑल दीज. I should add all these. So what will be the observability here? Output की observability which is 3 plus इसका 1 plus इसका CC0 is 3. So I should choose 3 and plus 1 for the level change, right? So value would be 3 plus 3, 6, 7, 8. So the observability at this wire becomes 8. What will be the observability here? 3 for output plus CC0 for the first wire which is 1 and CC0 for the last wire which is 3 plus 1. So again 8. So the observability of the second wire is also 8. What about the observability here? 3 plus 1 plus 1, 5 and plus 1 for the level change. So gives me 6. So the observability is 6. What will be the observability here for gate 5? आउटपुट की ऑब्जर्वेबिलिटी प्लस दूसरा इनपुट नॉन कंट्रोलिंग वैल्यू पे. नॉन कंट्रोलिंग वैल्यू ऑफ एंड गेट इज 1. सो CC1 of the other input which is 5. So 5 plus 0 plus 1, 6. So the observability is 6. For the lower wire here, 0 from output, 1 for CC1 plus 1 for the next level. So it becomes 2. So it is very easy to observe from here as compared to observing the output from here. Okay. Level 3 completed. So move to level 2. What should be the controllable observability here? This is giving you a fan out. Is fan out ka observability is 2. Here it is 6 and here it is 0. So what should you take? Minimum, that is 0. Because I can observe the value directly at this primary output. Why should I move through the other logic gates? So I took the minimum of the observabilities in the fan out. So I took it as 0. Now if my output observability is given as 0, what will be the observability for the top wire? This is an AND gate. So non-controlling value is 1. So the observability will be the output observability plus CC1 of other input, that is 2 plus 1. So it gives me 3. Okay, so you try it for the rest of the values. We'll work out in the next class.